Hello Slyfox community. In this video we are going to see how to write Verilog code for full adder, which is consisted of two half adders. You can see the schematic of the full adder that we are going to write the Verilog code for. We already know what is a half adder and how to write Verilog code for this. And as you can see, our inputs are connected to our first half adder, and our carry in is connected to second half adder, and the sum bit is generated automatically through the sum bit of the second half adder, and the carry out bit is constructed through ORing the carry out bits of our half adders. Explanation is enough. Let's see how to write Verilog code for this full adder. This is my Verilog code for the full adder. First, I define a module called half adder, and I called it HA. It has two inputs, A and B, and it generates two bits, sum and carry out. As we already know, the sum bit is produced through XORing our inputs, and carry out bit is constructed through ANDing our inputs. This is the required code for the half adder, and we will use this module in our full adder definition. This is our full adder module, and we write code for this. As you know, full adder takes 3 bits as inputs, A, B, and carry in, and generates 2 bits for us, sum and carry out. Before proceeding, we must declare 3 wires. I've called it sum of first half adder, carry out of first half adder, and carry out of the second half adder. These are used for interconnections within the full adder. You've already saw there are some interconnections between half adder blocks and XOR gate in this full adder. We define our first half adder through instantiation, and I call it HA1. I define its arguments in exactly the same order that I've defined the half adder module. First its inputs, then sum bit, and finally carry out. Here you can see it takes firstly its inputs, then sum bit, and carry out. It adds its inputs and store its sum bit in sum of first half adder, and puts its carry bit in carry out of first half adder. Then we define our second half adder, and I've called it HA2. Its inputs are carry in of the full adder, sum of first half adder, and then it puts the sum bit which has generated in the sum, which is the output of our general full adder, and its carry out gets stored in carry out of the second half adder carry out, which is a wire, and you can see here. And our final carry bit is constructed through ORing carryouts of half adders. You could see the required code for generating carry out bit. This is the necessary Verilog code for full adder. Now we're going to simulate it. Nice. As you can see, when all inputs are 0, our outputs are 0 as well. When only one of our inputs is 1, then we just get the sum bit and carry out bit is 0. This is true for this condition as well. Just one of the inputs are 1, and we got only the sum bit. When 2 of our inputs are 1, our sum bit is 0, and we got carry out bit to be 1. In this situation, just one of the inputs is 1, and we only get sum bit to be 1, and we don't have carry out bit to be 1. 2 of our inputs are 1, so sum bit is 0, and we only get carry out bit to be 1. 2 inputs are 1, and only carry out bit is 1, and sum is 0. And when all the inputs are 1, we've got both sum bit and carry out bit to be 1. If you are interested in seeing the schematic of your design, you can head to RTL Analysis, open Elaborated Design, and select Schematic. Then you could see the schematic of your design. For simulation, you also need to write Testbench. And this is the Testbench that I've written for the full adder. And I've tested different inputs, and we've already seen the result. If this content was useful for you, don't forget to give the thumbs up and subscribe to our YouTube channel for more electronics content. The source code and project files are available in my GitHub repository as well, and the link is provided. Good luck.